Hello everyone, welcome to our video. In this video, we are going to present to you about our mini project titled Temperature Sensor using ARM7 LPC2138 Microcontroller. This video is prepared by me, Muhammad Amir Akmal bin Abdul Razak, and my fellow group members Muhammad Rizman Hakim bin Sapari and Muhammad Kiwamuddin Fayad bin Norazman. This video is dedicated to Dr. Izhar bin Abdul Halim. So, in this video, we are going to present you about the introduction for our mini project, the components used for our mini project, the block diagram, the methodology for our mini project, circuit schematic design, program coding, and lastly, the circuit simulation for our project. So now let's move to the introduction. One of the main objectives of our mini project is to detect temperature or body temperature. Since now we are facing with the COVID-19, this mini project perhaps can help many people. LM35 temperature sensor converts temperature into its proportional analog voltage value. LM35 is a 3-terminal device. Pin number 1 and 3 are for 5 voltage supply. Pin number 2 is an analog voltage output with respect to the temperature value. Relation between measured temperature and the analog output voltage is 1 degree Celsius equal to 10 mV. Hence, for every 1 degree increase in temperature, there will be an increment of 10 mV in output voltage of LM35 sensor. ARM7, or the other name is LPC2138, is used to measure analog voltage value. ARM7 microcontroller is built-in ADC, which is analog to digital converter, is used to measure analog voltage value. ADC has been used to read analog voltage. After reading ADC value, using voltage and temperature relationship, voltage is converted back into its temperature. A conversion factor is used to convert voltage back into temperature. All this conversion has been done through programming. The output of the system, which is LED, will turn on the specific temperature as declared in the programming. So these are the components used for the hardware implementation. Firstly, we will need the ARM7 LPC2138 microcontroller. Next is the LM35 temperature sensor, a breadboard, jumper wires, 10 kilo ohm potentiometers, LED and LCD display. So now let's move to the block diagram. Firstly, we will need a power supply, and also we will need an LM35 temperature sensor to detect the temperature from the power supply, and both of these will connect to the ARM7 LPC2138 microcontroller. Hence, the output will display at the LCD and the LED. So now let's move to the methodology for our project. At the beginning of the program, the system will declare the variables, which is in the power supply. We will insert the input value for the voltage. Next, it will set value for related variable temperature, and then it will check the ADC sensor LM35 data. If the temperature is over 37.7, it will display on the LCD and the LED. Hence, the program will end. But if the temperature is not over 37.7, it will still display on the LCD but not to the LED. So now we move to the circuit schematic design. So this is our circuit schematic design for our project. As you can see, we have the voltage power supply, the LCD display, and the LED, which will later be explained in the circuit simulation. So now we will move to Kiwamuddin Fayad for the programming coding.
So now we move to the coding part. So for the first part, we have the global declaration in our program from line 2 until line 24. This includes the ADC and the LCD pin. From line 2 and until line 6, we have the ADC global declaration, and then we have the LCD global declaration, which is for pin register select, read write, and enable from line 7 until line 9. On line 10, we have the defined LCD control pin, In line 11 until line 14, we have the LCD data pin of D4, D5, D6, and D7. And in line 16, 17, and 18, we have the pin that will set when the X is equal to 1 and we clear if X is equal to 0. We also define the direction of the data pins and control pins as output on line 20 and setting as output for both data and control pins in line 21.
So we move to the next part. So basically there are 1, 2, 3, 4, and 5 functions, which is basically to put the delay for the LCD. As we can see here, every line after the LCD they will have a delay, so that it will create the delay for the LCD. So now we look at line 107, which is the int LCD go to XY function. So first the return value is equals to 0, and we check with the if function. If x is greater than 1 and y is greater than 15, the red value will equals to -1. Else if x is equals to 0, it will command the position cursor at 0x00 in bracket 0x0 plus 0x00. Else if x is equals to 1, it will command the position cursor at 0x40 in bracket 0x80 plus 0x00, and then it will return the red value. Okay, now is the important part of our program, which is the main body. So we will start with the initiate ADC033, which will pass the channel number and the clock division. This value 1 is equal to 46 is the ASCII value for dot. So next is while 1. So the value is equal to read ADC0 function. And then we will go to the LCD initiate LCD clear function, which is basically the delay function for the LCD that we discussed earlier. And then we will go to LCD go to XY with the x is equal to 0 and y is equal to 0 to find the value of val. And then when the val is written from the LCD go to XY function, the val will be calculated with equals to float vals times 1000 over 0x175 times 3.3. 3.3 is the V reference that we use in this program, which is 3.3 volt. And then we will calculate the value of A. So the A is equal to val over 1000 plus 1. So we will check the value of A with the if. If A is greater than 1, which means that the temperature read is higher or equals to 37, the LCD will bring the danger. And IO DI1 is set to 0x00FF0000, and IO1 set 1 when it is less than 16, which will make all the ports spin as high. So else, if A is not greater than 1, the LCD will print normal as the temperature read is lower than 37, and the IO clear 1 is set to 1 when it's less than 16. Okay, and lastly we will look at the void initiate ADC0 function, which is basically in the main body function. So first of all, we will select the AD0.3 of PO.30, and then on line 170 we will power on the AD converter, and the next line will configure the AD control register of the AD0. After that, we move to the unsigned integer rate ADC0 function, which the first step will stop the AD converter by masking the start bits and channel selection bits, and then it will select the AD channel in line 174 and start the AD conversion in line 175. In 176 is the while function. We will wait for the conversion to get over by monitoring the 28th bit of AD data register. The next line will stop the conversion by masking the start bit and capture the results by shifting the bits to 6 places to right in line 178, and then it will return the I value in line 180 to the main body function. And lastly is the delay routine for the display purpose. So it's basically the delay that we created for the display so that it will not go too fast.
So now we are going to demonstrate to you the simulation of the project and how it exactly works. As what we can see on the screen now, this is our schematic diagram for this project. We can see LM35 as the temperature sensor. Also, the input of this microcontroller chips is connected to the pin 15. We also can see the first output of this project, which is LCD screen, where the reminder or notice will be displayed on the screen. It's connected to the pin 35, 37, 38, 39, 4, 40, and lastly is pin 36. The last component that we can see here is the red LEDs together with 100 ohms of resistor. These LEDs are connected to the same pin, which is pin 16. As the function of this project, the danger notice will be displayed on the LCD screen when the temperature hits 37 degrees Celsius and above. Also, the both red LEDs will be light up for the same case. And when the temperature is below 37 degrees Celsius, the normal notice will be displayed on the LCD screen and the LEDs will not be light up. So now I'm going to simulate the simulation of this project. So we can see here the temperature 36 degrees Celsius is detected to LM35 and normal notice will be displayed on the LCD screen. Now I'm going to increase the temperature for the LM35. Now we can see 37 degrees Celsius is detected at LM35. We can see here the danger notice is displayed on the LCD screen. Also, the red LEDs are light up. So that's all for the simulation. Thank you.
So, in conclusion, the project is run successfully with the cooperation of the group members. We also obtained knowledge on using the ARM7 microcontroller. We gained new knowledge on how to use Proteus IC software and trial software. And lastly, we also learned how to simulate the circuit and how to configure the error in the coding. So, that's all from us. Thank you for watching this video. Hope to see you guys soon.